Our class today is about three-phase circuit or power system circuit. So what is three-phase system? Three-phase system is a system produced by a generator consisting of three sources having the same amplitude and frequency but out of phase with each other by 120 degrees C. Okay, this is example of three-phase system where you have three sources, which is 1, 2, and 3. And this one here is known as source. The line is here, 1, 2, 3 line here. So this one is considered a line. There is a source, line, and you have load. So they are out of phase by 120 degrees C. You have three line, and actually because of they are three phase, and is a neutral. So this is example in real. You see where the three-phase system is being used. So this is example of power transmission here, and it uses a balanced three-phase configuration. So in three-phase system, three-phase generator can be driven by constant force or torque. In industrial applications such as high power motor is being used in this three-phase system, welding equipment, and also use a three-phase system. So in three-phase system, there are three-phase generator consists of a rotating magnet known as rotor surrounded by a stationary winding which is stator. So it's here stator and here is rotor. So there are phase difference between VAN, VBN, and VCN by 120 degrees C. So what you need to know in this three-phase system, what is three-phase circuit? In this three-phase circuit, there is a source, line, and load. So you have to know where is the source, where is the line, where is the load. So this three-phase system is a balanced three-phase system. It can be analyzed by 4 different connections, which is from Y to Y connection, Y to delta connection, delta to delta connection, and delta to Y connection. And how to get all the unknown, where you need to calculate the line voltage, phase voltage, line current, phase current. Alright, what is the total power of a balanced three-phase circuit? So this is all the important parameter that you need to know in this chapter. So this is example of three-phase circuit. This is Y connection, for example. You have A, B, and C. N is for neutral line. So VAN is located here, VAN, VBN, and VCN. Balanced three-phase system, they have same magnitude, VM, and there are 120 degrees C phase shift. Because they are wave like this, so they are calculated by in time domain. VAN equals to VM cos omega t. VBN equals to VM cos omega t minus 120 degrees C. VCN equals to VM cos omega t plus 120 degrees C. So balanced three-phase system for the current have same magnitude, and they have also phase different 120 degrees C phase shift. Also same, IA equals to Im cos omega t minus theta. IB is equals to Im cos omega t minus theta minus 120 degrees C. IC is equals to Im cos omega t minus theta minus 240. So there is a phase sequence. You have to know either it is in the positive sequence or negative sequence. This one is in time domain. So this one is if we convert in the magnitude and phase. So VAN, you already know VAN, where is a VBN, where is VCN. VAN in the positive sequence, VAN is equals to VM or VP at the angle of 0 degrees C. VBN equals to VM at the angle of negative 120 degrees C. VCN equals to VM at the angle of plus 120 degrees C. This is for positive sequence. Negative sequence, VAN equals to VM at the angle of 0 degree. VBN, so it have plus. This one is minus, this one is minus, this one is plus. So that's the difference between positive and negative sequence. So this is the phase representation for the positive sequence and negative sequence. Alright. So balance voltage, phase voltage. Phase voltage usually refer to the source. All phase voltage are equal in magnitude and are out of phase with each other by 120 degrees C. So you already know previously at the angle of 0, at the angle minus 120, at the angle of negative 120. But the magnitude is the same. For the balanced load, the phase in impedance are equal in magnitude and in phase. So this is the phase quantity that you have to know, where you will need to measure the phase current, line current, phase voltage, line voltage. Phase voltage is measured between the neutral and any line to neutral voltage. Line voltage is a measure between any two of three lines, line to line voltage. Line current, IL, is the current in each line of the source or load. Okay, you remember you have 1, 2, 3, where you have line A, B, and C. Phase current is the current in each phase of the source or load. You have source here and load here. Three-phase connection. As I introduced to you before, we have Y-Y connection, Y to delta connection, delta to delta connection, delta to Y connection. Later, I will show you the example for Y-Y connection, Y delta connection, delta delta connection, and delta Y connection.